My name is Brad Remillard, and I'm a sophomore in the AT program. For my project, I did a retrofitted duck decoy. A little bit of background: I'm a pretty avid hunter. I hunt every weekend that I'm home in the fall, and we just bought a battery-powered duck decoy that just spins on the water. It kicks up the water, gives it some motion, and one problem with it is that the batteries die fast. They're 2D cell batteries, so it has 3 volts, they're in parallel, and we can go out for 2 or 3 hours and have to put new batteries in it the next time we go out. It's pretty inefficient. And the way they have it hooked up, it only goes in one motion, it only spins, it doesn't go forward or swim around or anything, it just stays in one spot. The system diagram, I have a blind up there, hopefully me in it, with my remote, and I just hit a button and it sends a signal to the decoy that will turn it on, make it go forward, spin left, spin right, and I also have a little LED on there because it has a pin on the receiver that will detect any button press, and it'll go high, so I'm going to use that to basically show that it actually received it, because I'm going to be in my blind. I'm not going to be able to tell if it actually got it or not. So this is my electrical concept diagram. I have my battery pack, which goes to a switch which is already on the decoy. It goes into a power fix because the motors, when they turn on, they bog the battery pack down, and I can turn the micro off if it goes too low. I'm going to pulse width modulate the motors so that it saves the power. It just high frequency turns them on and off. I have my new board, which has that verified transmission that I was mentioned with the LED. Then I have my remote that sends the radio signal to my board, and there's a receiver in the new board that will pick up that transmission. So here's a few parts of my schematic. This is the motor driving circuit. The micro pulse width modulates from A12, goes through this, turns these 2 transistors on, and they provide the current and voltage for the motors. I had to do a Darlington pair with those 2 resistors because I couldn't get enough gain to get the current that I need, because I need 300 milliamps out, and the 23904 couldn't put out that much current, and tip 31 only has a gain of 50, so I needed to combine them to give it a gain of about 10,000. And then this circuit over here is the LED circuit, so whenever that transmission line goes high, it'll turn the LED on so that I can know that it actually did turn on. Here's some of the waveforms that I took. This is actually the motor turning on, and it shows that the battery pack drops way down when the motors actually initially turn on, and then they kind of ramp back up. And then this is that transmission line that shows that no matter what button you push, it always goes high, and the longer you hold it, the wider the signal is. So some calculations I had was the beta for the Darlington pair. I checked the beta of the 2N3904 in the curve tracer, and it was beta of 200. And the tip 31 is 35, so that gives us beta of 10,000. The base current that I need, I calculated by the IC, which is 300 milliamps over beta, so I get about 30 microamps. And then the base resistor is 3.3 minus 1.4. The 1.4 is for 2 VBE drops, and then the IB, so you get 63.3 K. My mechanical design is the decoy weighs about 2.5 pounds, and at the widest part, which is right where the motors are, it's about 10 inches across, and its length is about 13.5 inches. For my software, I'm going to have the software actually wake up the micro. I'm going to have different routines with the buttons. So forward, left, right, and then I'm gonna actually have one of the buttons, when I hit it, it actually turns on the whole circuit so that it will be ready to go. Here's some test program. I have it, if one of the buttons goes high, this is for turning left, so I'd have to turn the right motor on. And I just have it on for 3 seconds and then shut off. Same with the left, turning right, I have the left motor on for 3 seconds, just so I can test. When I get a final product, I want it to have, if I want to turn left, I hit the button and it just keeps going until I hit another button, like turn right. Some issues I had was actually finding a remote, because at first I wanted to do like infrared, but one of the issues is that if it was sunny out, infrared wouldn't work, because anything that would shine would give off infrared waves, and it would interfere with my remote signal. Another thing is long distances. I was going to do ultrasonics or even like a laser, but you have to take into account the distance, because ultrasonics is only good for like 10 to 15 feet. I'm going to be at 20 yards, so about 60 feet at the minimum, so I need something that can go a long way. Another thing that came up was low voltages. The chip that is the receiver is rated to 3 to 5 volts, and I tried it at 2 volts, and as we can see, I'm pressing the button and nothing is coming up. But I tested the voltage on my batteries at this moment, and it was 2.5 volts. So I set it to 2.5, and I still get a signal out. So it works, and that's another way I'll know if the batteries are dying, when it stops accepting a transmission. Environmental impact. It's more efficient with the pulse width modulation, because it's turning the motor on and off. It's not just fully on all the time. I'll have less waste, because I won't be going through 2 D-cell batteries every time I go hunting. And it has ethical hunting practices, because when you have decoys like this, you're attracting the ducks a lot closer to you, so you're taking shots that are a lot closer. You'll have a lot more humane kills and a lot less wounded birds. Here's my finished product. This is a top view. That just shows the width and the length, and there's a side view of the motor. I'm planning on putting the light somewhere right on top so I can see it from my blind. I just wanted to say thank you for Professor St. Dennis for all the help, Bob for cutting my board and getting anything that I needed, and then the class for anyone who's helped me. Thank you. And questions?
Have you done any of the pulse width modulation stuff with the motors yet?
I haven't tested that yet.
software is just fully on. Okay.
Yeah, that's just fully on, fully off. I wanted to get that working and then do the pulse width modulation.
Do you have a goal for how long the battery should last?
I would like it to last at least 2 outings. Sometimes we go, 5 hours, but this won't be on that long. We'll turn them off. We'll try stuff different. But I'd like it to at least last 4 or 5 hours, where right now it's about 2 or 3.
I think we talked, again, with the software, consider doing something like where you slowly turn on the motor,
Yeah.
run for a while,
Yeah.
and turn them off, and then, wait 15 seconds and let it do it again. And so
Yeah, that's something else that I was thinking about.
I think you got to start thinking like a duck, right?
Yeah.
Whatever a duck
Yeah.
is doing.
Right.
Have you thought about putting any loops in your code where you press a button and the bird will just make some predetermined movements, and then you can put the remote down and go to your shotgun and do it?
I thought about that, and the remote only has 4 buttons, and I know one is going to be a power button, and I wanted one so that I could make them both go forward in case I wanted it to swim in a different place. So I thought about it, but I haven't actually done it, because I'm going to have the right and left controls as well.
Yeah.
But maybe in a future design I can make one that has like a little dance routine on it or something, so it swims around.
Well, I think you can play and experiment and see if you come up with something, you might not need the left and right control.
Yeah.
Completely. You can always go with a double click situation.
Okay. Yeah, that would
There's
work
lots
too.
of interesting patterns you can do with that. Any other questions?
So instead of an LED or something on top, if you think about putting like a duck call on it to confirm your remote pushing?
That would be cool, but I think the game warns wouldn't like that because you're not supposed to have any electronic calls, but if I could, I probably would do that.
That's a bummer, that'd be cool. And you wouldn't need a duck call either.
Yeah. Any other questions?
How far can your remote reach?
Oh, that's a good question. It has a range of about 200 meters, which is way further than I need it for. I only need it for like 20 meters or so. Any other questions?
Thank you.